Ever wondered what our world would be like if giant insects from prehistoric times made a comeback? It sounds like something straight out of a monster movie, right? But what if I told you that the key to this ancient world of giants wasn't some magical spell or a mad scientist's experiment, but something as simple as oxygen? 300 million years ago, our planet was a very different place. This was the Carboniferous period, and Earth was basically a giant, steamy jungle. Plants were growing like crazy, and through photosynthesis, they were pumping massive amounts of oxygen into the atmosphere. How massive? Well, today, our air is about 21% oxygen. Back then, it was a staggering 35%. This oxygen-rich environment had a truly wild effect on life, especially on insects and other arthropods. Imagine dragonflies with wingspans as wide as a modern eagle, or millipedes stretching over 2 meters long, scuttling across the forest floor like armored trains. Scorpions the size of a small dog? You bet. This wasn't science fiction. This was the reality of the Carboniferous period. So, what's the connection between oxygen and giant bugs? It all comes down to how they breathe. Insects don't have lungs like we do. Instead, they have a network of tiny tubes called trachea that deliver oxygen directly to their cells. This system is super efficient, but it has a limit. The bigger an insect gets, the harder it is for oxygen to travel all the way through these tubes. In today's 21% oxygen atmosphere, this system puts a natural size limit on insects. But in the high oxygen world of the Carboniferous, that limit was pushed way, way up. With so much oxygen in the air, it could easily penetrate deeper into their bodies, allowing them to grow to monstrous sizes. They were basically supercharged. But it wasn't just about breathing. This surplus of oxygen fueled a high-energy ecosystem. With more fuel, everything could get bigger and more active. For predators like the giant dragonfly Meganeura, it meant they had the energy for sustained, powerful flight to hunt. For the giant millipede Arthropleura, it meant having the metabolic power to move its huge armored body. Now, you might be thinking, could this happen again? Could we see giant bugs return? Well, it's a fascinating thought experiment. To recreate the age of giants, we'd need to dramatically increase the oxygen levels in our atmosphere. This would mean a massive worldwide surge in plant life, far beyond anything we have today. We're talking about covering entire continents in dense, fast-growing forests. Let's imagine for a moment we could do it. What would that world look like? At first, it might seem great. We'd probably feel more energetic, more athletic. Athletes could break records left and right. But there would be a huge, fiery downside. With 35% oxygen, everything becomes incredibly flammable. A single spark from a lightning strike could ignite a forest fire that would be almost impossible to extinguish. Even damp vegetation would burn like it was soaked in gasoline. The world would be in a constant state of high alert for catastrophic fires. And then there are the creatures themselves. If insects did start to evolve back to their giant forms, our world would change forever. Imagine trying to have a picnic with ants the size of your hand, trying to steal your sandwich. Or imagine a dragonfly with a 2-foot wingspan crashing into your car's windshield. Our homes, our cities, our entire way of life is built for a world with small insects, not giant ones. Pest control would become a military operation. Agriculture would be a constant battle against colossal herbivores. A swarm of giant locusts wouldn't just be a problem. It would be an apocalyptic event. The balance of nature would be completely thrown off. Predators and prey would be locked in a new, supersized evolutionary arms race. Of course, this is all highly speculative. The evolutionary path that led to those giants took millions of years. It wouldn't happen overnight. And besides, there were other factors at play. The lack of flying vertebrate predators like birds certainly gave insects an open sky to conquer. But studying the Carboniferous period gives us an incredible window into how interconnected life on Earth is. It shows how something as fundamental as the air we breathe can shape the evolution of an entire planet's inhabitants. It's a powerful reminder that our world exists in a delicate balance. The oxygen levels that allowed giant bugs to thrive were also what created the vast coal deposits we use for energy today. Those ancient forests, packed with carbon, were buried and compressed over millions of years. So in a way, we are literally burning the remains of the age of giants to power our modern world. It's a strange and fascinating connection, isn't it? The same element that created a world of monsters is now, through our use of fossil fuels, changing our climate in profound ways. The story of Earth's oxygen is a story of dramatic change, of life adapting in incredible ways, and of the deep, often invisible forces that shape our world. So next time you see a dragonfly zipping by or a millipede crawling on the ground, take a moment to imagine its ancient ancestor. Imagine a world buzzing and crawling with giants, all thanks to a little extra oxygen. It is a humbling and awe-inspiring thought that shows just how wild and wonderful the history of our planet truly is. Have you ever swatted a fly or stepped on a bug and thought nothing of it? Now, imagine if that bug was the size of a car. What if our entire world was suddenly overrun by giant insects, turning us from the rulers of the planet into just another item on the menu? It sounds like a B-movie plot, but what would really happen if insects became colossal? How would our modern civilization, with all its technology and power, actually stand up to this six-legged nightmare? Let's dive into this terrifying thought experiment and see how quickly our world would crumble. First, let's set the stage. For this to happen, a few laws of physics would need a serious rewrite. The main reason insects can't get huge is their respiratory system. They breathe through tiny tubes called trachea. If an ant were the size of a bus, it wouldn't be able to get enough oxygen to its massive body. Its exoskeleton would also be too heavy to support its own weight. But let's imagine some freak evolutionary event or alien intervention solves these problems. Suddenly, insects are not just big. They're supersized and super strong. The first few days would be pure chaos. Imagine looking out your window to see a praying mantis, now as tall as a building, slicing through cars with its forelegs. Or a swarm of hornets, each the size of a small plane, descending on a city. The initial shock and panic would be overwhelming. Emergency services would be the first to fall. How can a fire truck fight a fire-breathing bombardier beetle? Or a police car stop a rhinoceros beetle powerful enough to derail a train? Our conventional weapons would be surprisingly ineffective. Bullets might just bounce off the thick chitinous armor of a giant beetle. Even military-grade hardware would struggle. A tank shell might crack an exoskeleton, but what happens when you're facing a swarm of thousands of giant ants? Within a week, cities would become death traps. The intricate systems that keep our urban centers alive would shatter. Power grids would fail as giant insects tear down power lines or nest in power plants. Water supplies would be contaminated or cut off entirely. And most terrifyingly, the food supply chain would cease to exist. Giant locusts could devour entire states' worth of crops in a single day. Herds of livestock would be easy prey for gigantic predatory wasps or spiders. Supermarket shelves would be bare in hours, leading to widespread panic and resource riots among the surviving humans. People would be forced to abandon the cities, which have now become giant insect nests and hunting grounds. So where would people go? The instinct would be to head for the countryside, to get away from the concentrated chaos of the cities. But rural areas would present their own set of horrors. What was once peaceful farmland is now the territory of colossal herbivores and the even larger predators that hunt them. Imagine a caterpillar the size of a school bus munching its way through a forest, or a centipede as long as a freight train burrowing just beneath the soil, ready to erupt from the ground and snatch anything that moves. Underground shelters might seem like a safe bet, but they would be prime real estate for giant ants, termites, or trapdoor spiders. And let's not forget the water. Lakes and rivers would be patrolled by monstrous dragonfly larvae and diving beetles, making any boat journey a deadly gamble. As weeks turn into months, human society would fragment. Large-scale governments would collapse, unable to protect their citizens or coordinate any meaningful resistance. Communication would be almost impossible without satellites and internet infrastructure. We'd be back to a pre-industrial state, but with the constant threat of being eaten. Small pockets of survivors would form, likely in fortified, isolated locations. Perhaps in cold, mountainous regions where the colossal, cold-blooded insects struggle to survive. Or maybe on remote islands, hoping the giant bugs can't cross the vast expanse of the ocean. These survivor communities would face a brutal existence. Humanity's greatest strength has always been our intelligence and our ability to build tools. We would have to adapt fast. Instead of hunting deer, we'd be hunting housefly-sized insects for protein, while trying to avoid becoming prey ourselves. We would learn the insects' behaviors, their weaknesses. Maybe we'd discover that certain sounds repel them, or that their joints are less armored. Our engineering skills would be repurposed not for building skyscrapers, but for creating defenses. We'd build walls from scrap metal and concrete, design new weapons capable of piercing thick exoskeletons, and develop traps based on insect biology. But even with our ingenuity, the odds would be stacked against us. The sheer numbers of the insect world are staggering. For every human, there are millions of insects. Now imagine those millions are all giants. They reproduce at an incredible rate. A single queen termite can lay an egg every few seconds. How could we possibly fight a war of attrition against an enemy that can replace its fallen soldiers almost instantly? We would be constantly on the defensive, our existence a desperate daily struggle for survival. And what about the planet itself? The rise of giant insects would dramatically reshape the global ecosystem. Massive insect herbivores would consume forests at an alarming rate, leading to desertification. The immense biomass of the insects would change the composition of the atmosphere. The world would look, sound, and even smell different. The constant buzzing, chirping, and clicking of these behemoths would be the new soundtrack of the planet. Our once dominant civilization would become a footnote in Earth's history. Our cities' crumbling ruins overgrown with strange new flora, a testament to the time when tiny mammals thought they were in charge. Ultimately, humanity's reign would be over. We might survive in small, scattered, terrified groups, hiding in the shadows of our new insect overlords. We would be a species living on borrowed time, telling stories of a past when the world was ours, a world before the bugs got big. It's a terrifying thought, and it really puts our place in the world into perspective. We see ourselves as the pinnacle of evolution, but perhaps we're just living in a temporary lull between the age of dinosaurs and the age of something far, far scarier. So the next time you see a spider in the corner of your room, maybe give it a little nod of respect. In another reality, it might just be the landlord. Picture this. Earth is on the brink. Our climate is spiraling out of control, ecosystems are collapsing, and humanity is desperate for a solution. Scientists, in a bold and controversial move, turn to the past. Not just to learn from it, but to bring it back. They propose de-extinction, not just for woolly mammoths or dodos, but for something far more ancient, far more powerful. They want to revive the colossal, terrifying creatures of the Carboniferous period, to re-engineer our planet's atmosphere. What could possibly go wrong? Welcome back to the channel. Today, we're diving into a speculative world where de-extinction isn't just a scientific curiosity, but humanity's last-ditch effort to survive. Imagine a world where the very monsters we thought were confined to fossil records are brought back to save us. The theory sounds almost brilliant on paper. 300 million years ago, during the Carboniferous period, Earth was a different beast entirely. The air was thick with oxygen, nearly 35%, compared to our 21% today. This oxygen-rich environment allowed life to grow to monstrous proportions. Giant dragonflies with wingspans like eagles, millipedes the size of cars, and spiders as big as your head. But the key players in this plan weren't the nightmare bugs. They were the plants. Vast, swampy forests of towering lycopsid trees and colossal ferns covered the planet. These ancient plants were incredibly efficient at one thing: pulling carbon dioxide out of the atmosphere. When they died, they didn't fully decompose. Instead, they were buried, and over millions of years, the immense pressure turned them into the coal and oil we burn today. They locked away gigatons of carbon. So, the plan is hatched, Project Carbon Sink. The goal: resurrect these superplants and let them do what they do best. Scientists use advanced genetic engineering and CRISPR technology to piece together fragmented DNA from fossils. After years of trial and error in massive sealed biodomes, they succeed. They grow the first Carboniferous forest in 300 million years. The initial results are staggering. The genetically engineered trees grow at an accelerated rate, and within a decade, CO2 levels in the atmosphere start to show a noticeable drop. The planet begins to breathe a sigh of relief. The project is hailed as a miracle, the ultimate triumph of human ingenuity. Governments pour trillions into expanding these neo-Carboniferous forests across the globe, converting barren deserts and deforested lands into lush, alien jungles. With the success of the flora, the project's scope expands. To create a truly balanced, self-sustaining ecosystem, the scientists argue they need the fauna too. Not just the plants, but the animals that lived among them. They start small, reviving ancient insects to act as pollinators and decomposers. But the temptation to go bigger is too strong. They bring back Arthropleura, the 10-foot-long millipede, to help break down plant matter. Then comes Meganeura, the giant dragonfly, to control smaller insect populations. The public is mesmerized and terrified. Zoos are replaced by paleoparks, where people can safely view these resurrected giants from behind reinforced glass. It's the greatest show on Earth, but nature has a way of reminding us that it can't be perfectly controlled. The first sign of trouble comes from the atmosphere itself. The rapidly growing forests are not just sequestering carbon. They're pumping out oxygen. So much oxygen. The atmospheric content creeps up from 21% to 23%, then 25%. Scientists assure everyone it's a manageable side effect. But the higher oxygen levels have an unintended consequence. They supercharge the resurrected creatures. The giant insects, already enormous, start growing even larger than their fossil records suggest. Their metabolisms go into overdrive. They become more aggressive, more territorial. The first incident happens at a research outpost in the Amazonian Neocarboniferous zone. A team of botanists goes missing. A rescue mission finds the outpost destroyed, ripped apart by something immensely powerful. All they find are strange, deep gouges in the metal and a single shed fang the size of a man's hand. It doesn't match any known resurrected species. Panic begins to set in. The scientists re-examine the ancient DNA they used. They discover something they missed, something hidden within the genetic code of the plants and smaller animals. Fragments of DNA from apex predators, creatures they had no intention of reviving. It seems that in their rush, they inadvertently resurrected predatory DNA that lay dormant. Perhaps it was from contamination, trace DNA left on fossils, or even a horizontal gene transfer event from millions of years ago. It turns out the high oxygen, carbon-rich environment acted as a trigger, the perfect incubator. And something new, something unexpected, has woken up. They call it the carbon wraith. It's not a single species, but a horrifying amalgamation. A genetic chimera born from the soup of resurrected DNA. It has the armored shell of an ancient arthropod, a predatory instincts of a primordial amphibian, and a size that dwarfs anything they had planned for. These creatures are fast, intelligent, and perfectly adapted to the new alien world humanity has created. And they are breeding rapidly. The walls of the paleoparks and research zones are no longer enough. The carbon wraiths, with their immense strength and surprising cunning, break through the containment fields. The dream of saving the world turns into a global nightmare. The giant insects, once a spectacle, are now a plague of biblical proportions. Flocks of Meganeura descend on cities, their buzzing wings sounding like helicopters. Arthropleura, now the size of buses, plow through buildings as if they were made of cardboard. Humanity finds itself in a new war for survival. A war not against each other, but against the very monsters they created to be their saviors. Our conventional weapons are surprisingly ineffective against the thick carapaces and sheer size of these creatures. The high oxygen air that gives them strength makes our own fires and explosives burn hotter and more uncontrollably, often causing more damage to us than to them. Cities become fortresses. The sprawling neo-carboniferous forests, once a symbol of hope, are now no-go zones, the hunting grounds of the carbon wraiths. We are driven back, forced to live in fortified zones, watching the world we tried to heal be reclaimed by a primeval wilderness. The irony is crushing. In our attempt to reverse climate change, we didn't just bring back the past. We unleashed a force of nature far more dangerous than rising sea levels. We traded a slow, creeping apocalypse for a fast, tooth and claw one. The story serves as a powerful cautionary tale. It highlights the hubris of believing we can perfectly control complex natural systems. Ecosystems are not machines with interchangeable parts. They are intricate webs of life, developed over millions of years, with checks and balances we are only beginning to understand. Pulling on one thread can unravel the entire tapestry in ways we can never predict. The idea of de-extinction is incredibly seductive. Who wouldn't want to see a woolly mammoth roam the tundra again? But this story forces us to ask a crucial question. Just because we can, does that mean we should? Are we prepared for the unintended consequences? When we play God, we must be prepared to deal with the monsters we create. What do you think? Is de-extinction a tool that could save us, or is it a Pandora's box that should remain firmly shut? Let me know your thoughts down in the comments. This was a wild thought experiment, and I'd love to hear your take on it. Thanks for watching. If you enjoyed this journey into speculative science, be sure to hit that like button and subscribe for more deep dives into the what-ifs of our world. Until next time, stay curious.